All right, second problem here. This is also a higher order linear differential equation, just like the previous one, except for this time we have some initial conditions. So we're going to have to solve for our C values. So the first thing we do with these is we always find the characteristic equation. So that gives me r cubed minus 4r squared minus 21r equals 0. I could factor my r out to get an r times r squared minus 4r minus 21 equals 0. From there, this one's easier than the previous one, which had complex pieces in that inner piece, because this factors. This factors down to r, open parentheses, r minus 7, and then r plus 3 equals 0. That gives me 3 r values. R equals 0, 7, and negative 3. So what that does is those become my exponential pieces. X is equal to e to the, well, here. You should know that e to the 0t is just 1. So for this first one, instead of writing c1 times e to the 0t, I just write c1, because e to the 0t is 1. Plus c2 times e to the 7t, plus c3 times e to the negative 3t. So if this was not an initial value problem and I was just looking for the general solution, that would be it. Instead, I now need to derive and use some methods to figure out what these initial values here do to the C values. So what C values do I get out of them? All right, so first thing I need to do is derive x prime is equal to, the C1 goes away. I get a 7C2 e to the 7t, and then minus 3c3 e to the negative 3t. I got to derive again because I need to be able to use this double derivative information right here. That gives me x double prime is equal to 49 c2 e to the 7t, and then I get a plus 9c3 e to the negative 3t. Just some chain rule there. So from here, I'm going to use these initial values. So what does that give me? I'm going to plug in the values here, which gives me, all right, so the first one says 3 is equal, as that says x of 0, so it's going to go in for this line, is equal to, all right, c1 plus, I'll do this once. So this has c2 times e to the 7t, but I'm plugging in t equals 0 right here. So that gives me c2 times e to the 7 times 0, which is the same as c2 times e to the 0, which is just c2. So for all of these, all of the exponentials are going to go away because I'm plugging in 0 for time, which is nice. So I get c2 plus, same thing will happen here, c3. I also get, all right, the 5 here gives me 5 equals, all right, there's no C1 anymore, but I get a 7C2 plus, not plus, minus a 3C3. Let's make it a little smaller. I, for the last one, get negative 3 equals, all right, 49C2 plus this time 9C3. So these, I'm going to go and put into a matrix. I love using matrices here because it does all the algebra for me. It prevents me from making silly algebra errors while I'm trying to do some calculus. So the first thing that I'm actually going to do is rewrite this for us. All I'm going to do is take these values and put them over on the right-hand side. So I can just grab them, move them over, and put my equal signs here and erase. All right, so all I did was switch the side that the equal sign are on. No change there to the equations. So actually, I'll do it right here. So I'm going to build out a matrix where this is equation 1. This is equation 2, equation 3, and then C1, C2, C3. I think I'm going to need a little bit more space. I'm going to put a bar, and then I'm going to put the right-hand side. So you can see here that this first equation has C1, so I'm going to put a 1 for that coefficient, a 1 for the next one, a 1 for that one, and a 3 for this one. Next one, there is no C1 coefficient, so I put a 0. Then I put a 7, and then I put a -3. The 5 is the right-hand side. And then I get another 0, and a 49, and a 9, and a -3. So the reason why I like these matrices is because it's really easy to do what's called RREF on it. It's reduced row echelon form. It's something that my calculator can do, and it'll tell me what the C1, C2, C3 values are. So I like to write RREF to indicate what I've done. And now, all right, take a look. I am going to hit second on my TI-84 and hit the X inverse button. That takes me into the matrix menu. I'm going to go over to the right to edit, and I'm going to hit enter. First thing it's going to ask me for is the size. You can see that I've already made this one a 3x4. All you do is hit 3, enter, 4, enter, and then it'll give you a 3x4. It'll start with all zeros, but you want to put all these numbers in. You may say, where's the vertical line that I have right there? And actually, I see a little error there. But where's the vertical line? This vertical line is just here for us to visualize that there's an equal sign here. So let's double check what we have here. 1, 1, 1, 3. Good. All right, let's go over to here. 0, 7, -3, 5. Good. And then 0, 49, 9. All right, it should be a -3 here, not a -9. So that's actually a good demo, because a lot of times, like, you know, if you don't get an answer that you expect out of this and you're using your calculator, one of the first things I check is to see if I messed something up while entering it into the matrix. I will cross-reference this with what I was supposed to put in. So what do we do next? We quit. We go back into the matrix menu. I go over to the right, which is math. And for me, I like to pop around the top until I get to RREF, which is right here. And then, that's on my main screen there that I can see the RREF. I have to tell it what to do RREF on. So we're going to do it on, whoops, I don't need to go. I just pull up matrix A. If I wanted to do on matrix B, I would pull up matrix B. Hit enter. Don't need to close the parentheses. I get this. So I get these numbers right here. Now, if decimals are cool with you, that's fine. I prefer to use fractions when I can keep it accurate. So what's really, really nice about this on our calculator is we can math frac this. What I mean by that is I can hit the math button, and I can hit arrow frac, and boom, it'll give me these fractional values for my REF. Now, this, if you were to reverse engineer what we just did here with this matrix right here to go back to the equations, you would see that C1 is equal to this, and C2 is equal to this, and C3 is equal to this. And again, I way prefer doing this type of algebra with my calculator than doing it by hand. So I'm going to write those down. All right, here they are right here. I have my C values, and I got them from doing my REF. And now what I'm going to do is, let me change different colors. I'm going to use those C values with this right here. So that line and this line are going to come together. And that gives me my final answer, which is that X is equal to 81 over 26, sorry, 86 over 21, plus 6 over 35 times e to the 7t, minus 19 over 15 times e to the -3t. It's good like that. If you wanted to check it, you could add these three numbers up. If I've done everything correctly and add it up, I should get that 3 that I have right here. You could also start deriving and checking here, but I'm good to go. So that's our answer for this one. I hope that you see how to deal with the characteristic equation, how to get your R's, how to get the general solution, how to do some derivatives, how to use the initial values to create a linear system of equations, not differential equations, a linear system of equations, how to then make a matrix, REF that thing, get some numbers, and use that in the final answer.